Today's fact of the day is from combinatorics. The fact is, if A is a set containing m elements and B is a set containing n elements, and if m is less than or equal to n, m is less than or equal to n, then there can be npm one-to-one or injective functions from A to B. So how many functions that we can define from A to B which are one-to-one in nature? The number of functions that we can define from A to B, one-to-one functions that we can define from A to B is npm, or the same thing can be given by the expression n times n minus 1 times n minus 2 times and so on n minus m plus 1. So this expression gives the number of one-to-one functions that can be defined from a set A containing m elements and a set B containing n elements. The thing to be noted is, the point to be noted is, the cardinality of the set A is m and the cardinality of the set B is n, and the relation between the cardinality of the set A and B is given by m is less than or equal to n. So this condition is a must for functions to be of injective nature. Now let us see an example to understand this. Of course, this example is not a proof. As I have already said, there is a Jewish proverb, for example is not proof. For example is to understand the concept better, but this concept will be proved in the next lecture. Okay. For example, if A is equal to 1, 2, 3 having 3 elements and B is a set having 4 elements, then a function f from A to B can be thought of as a job. You can consider defining a function f from A to B as a bigger job. Okay, you remember the fact that defining a function from A to B is a bigger job. So we are considering that as a bigger job because we are going to apply the fundamental principle of counting. Okay, now note that the cardinality of A is 3 and the cardinality of B is 4, and also that 3 is less than 4. So the hypothesis, the condition about the cardinality is satisfied. Now what happens here is, this 1 can be mapped to any of the 4 elements. The 1 in A can be mapped to any of the 4 elements in B. So one has how many possible choices? One has 4 possibilities or 4 choices. So one can be assigned to an element in B in 4 ways. So you can assign 1 in 4 ways. Likewise, having assigned 1 to one of the elements, now the next element 2 in A can be assigned to remaining any one of the 3 elements. Without loss of generality, let us assume that one is assigned to A. One is assigned to A. Okay. So having assigned 1 to A, the next element 2 can be assigned to remaining any one of the elements B, C, D. Okay, because we said that the function is an injective function. So 2 cannot be assigned to A. Therefore, we have to assign 2 to any of the 3 elements. That can be done in how many ways? That can be done in 3 ways. So this is the second job that we are doing. The first job is assigning 1 to A. That can be done in 4 ways. Any of the elements that can be done in 4 ways. Okay. Job 2 is assigning 2 to any of the B, C, D, and that can be done in 3 ways. Without loss of generality, let us assume that 2 is assigned to B. What happens now? Having assigned 1 to A and 2 to B, now 3 has only 2 possibilities. Namely, 3 can be assigned either to C or to D. So 3 has only 2 possibilities. Now the third job is to assign 3 to either C or D. That can be done in 2 ways. So how many jobs are there? The bigger job of defining function consists of 3 smaller jobs, namely assigning 1 to any of the 4 elements. That can be done in 4 ways. Assigning 2 to remaining any of the three elements, that can be done in three ways. Assigning 3 to any of the remaining two elements, that can be done in two ways. So defining the function j, job, bigger job, consists of three smaller jobs, namely job 1, job 2, job 3. Okay, so a function is the bigger job of defining a function is considered to be done. So a function is defined only when all the smaller component jobs, namely j1, j2, j3 are done. Assigning 1 to any of the 4 elements, 2 to remaining 3 elements, and 3 to remaining 2 elements. If all the 3 jobs are done, then we can say that the bigger job of defining a function or defining a one-to-one function is accomplished. Okay. Why we have introduced the concept of job is because the bigger job is considered to be done only when all the three smaller jobs are done. So by fundamental principle of counting, the number of one-to-one functions or injective functions that can be defined from A to B is said to be accomplished only when those three jobs, namely assigning 1 to any of the 4 elements and 2 to any of the 3 elements and 3 to any of the 2 element is done. So that can be done in 4 ways, 3 ways, 2 ways. So when you multiply that, what do we get is 24. So how many functions that can be defined from A to B, which are one-to-one in nature or injective in nature, is 24 functions can be defined which are one-to-one in nature from A to B. So this is the answer, and that can be written as 4 factorial by 1 factor, which is nothing but 4p3. So this is the number of functions which are one-to-one that can be defined from A to B, and we will prove the result using principle of counting in the next video. Thank you for watching.